Hello and welcome to this learning video. In this learning video, we will continue with the same topic and taking more and more examples on this Fourier transform. So without wasting much of time, let us see what this problem says. So this problem says find out the Fourier sine transform of this and hence show that. So we will first concentrate on the first part. So we will first of all find out the Fourier sine transform of this. Okay. So as usual, let us start with these three golden words in mathematics. That is, we know that. So what we know? We know that. Before that, write down the given function first. So what is given function? Let f of x is equal to e to the power minus mod of x. Okay, and then we can start with the three golden words in mathematics, which says we know that what the Fourier sine transform the Fourier sine transform of f of x is given by what? Yes, do you remember that? Yes, that is Fourier sine transform of f of x, which we denoted by f bar of s is equal to, what is it? Yes, what is it? Under root, correct, under root 2 by pi integration 0 to infinity, yes, f of x into sine s of x dx. Is that correct? Integration under root 2 by pi integration 0 to infinity f of x into sine sx dx. Okay, now you have your f of x, you can just substitute, but as you can see we have limit 0 to infinity, means x greater than 0. So you can write here, for x greater than 0, e to the power minus x is same as e to the power minus x. Okay, because for x greater than 0, mod of x same as x. Now you can substitute here and write it as f s bar of s is equal to under root 2 by pi integration 0 to infinity. What is this? For x in 0 to infinity, for x greater than 0, we have this as e to the power minus x into sine s of x dx. Simple. Now you have to apply, either you can apply integration by parts or the formula that I have quoted in the previous learning video. So make use of that only, that will save much of your time. So this is like integration of this. So what is it? 1 upon coefficient of x square. What is coefficient of x? Minus 1. So its square is minus 1 square is plus 1. Next, coefficient of x, that is s square. Clear? Then write down e to the power minus x as it is, and in bracket you will be having minus 1 into sine of s of x minus, what is derivative of sine s of x? That is cos s of x into s, and then the limit 0 to infinity. Simple. Now this is under root 2 by pi. Okay, under root 2 by pi. What is this? This is apply the upper limit minus lower limit. So this is s square plus 1 you can write, right? Now e to the power minus infinity, e to the power minus infinity is 0. So 0 into anything 0. So upper limit this infinity will contribute to 0, whereas the lower limit 0 will gives you e to the power 0 into sine 0 is 0 minus 1 into sine 0 minus s into cos 0. Simple. Yeah. Now you can just solve this. So we'll be getting under root 2 by pi, this is my f bar s of s. So this is 0 and this is again 0. This is minus s into 1 and this minus become plus. So this is s upon s square plus 1. So this is my Fourier sine transform of this function e to the power minus of mod of x. Now I am gonna make use of this to show that this, and to show this I will make use of the inverse sine transform. Okay, so I can continue with here. We know that like the Fourier inverse Fourier sine transform. Now the inverse Fourier sine transform is given by, what is it? F of x is equal to, right? So you can write here fs inverse of inverse transform. So you can write like f of x is equal to Fourier sine inverse of this, right? Fs inverse of fs of s is equal to integral 0 to 2 pi. It should be fs power of s into sine sx dx. Okay, now we have the value of this, so just substitute there. So okay, let me rub this now. So this is my f of x, therefore f of x is equal to, what is it? Under root 2 by pi as it is, then integration 0 to infinity, what is fs bar of s? That is also under root 2 by pi into s upon s square plus 1 into sine sx dx. Simple. It is okay up to this. Okay, now this is all done. Now this 2 pi can be taken outside, so this is 2 by pi, and we remain with integration 0 to infinity. It should be ds, right? It should be ds, yeah, s upon s square plus 1 or 1 plus s square, whatever you can write. 1 plus s square or s square plus 1 into sine sx dx. Simple. Okay, what is my f of x? In 0 to infinity, my f of x is e to the power minus x. Okay, now look at the result that we have to prove. So in the result we have to put we have to prove something is equal to pi by 2 e to the power minus m. We have e to the power x. So the very first thing that you can do is you can just put, or instead of substituting, you can just replace x by m. We get, so what we get when you replace x by m? So I will be getting it e to the power minus m into this 2 by pi can be multiplied over here in the next step, and this is 2 by pi integration 0 to infinity s upon 1 plus s square into sine. I am replacing x by m, so this is x by m, so this is sm d, this is ds s. Okay, now just take this to here. So the moment you take this to here, so this would be pi by 2 e to the power minus m. That's okay. Now this is definite integration, and in the definite integration we can change like in one variable to another, but for the sake of our convenience I am just doing it. Put s is equal to x. The moment I put s is equal to x, what would be my ds? ds is equal to dx. Limits will remain changed. Put x is equal to, these are the limit of s. Put s is equal to 0, x is equal to 0, s equal to infinity, x equal to. Limits are unchanged. Limits are unchanged. So I am taking this to here. So this implies pi by 2 e to the power minus m is equal to, what is it? Integration 0 to infinity s. What is s? X. So this is x upon 1 plus x square into, what is sine? Sine, what is s? X. So sine mx dx. Okay, so as you can see, this is what the result we were looking for. So this is the required result. So in this problem, how we have approached for this problem, we have first of all find out the sine transform for sine, Fourier sine transform of the function, and then we'll get the result fs of s, and then we'll make use of that result that we have got from the Fourier sine to get this result by applying the formula of Fourier inverse Fourier sine transform. Okay, so thank you for watching this learning video and have a good day.